Hey guys, sorry I couldn't be with you today. Once again, I am home with my kids. So what we're going to do is start off with what we left off with yesterday, which is exactly what I told you we were going to do. So if you open up your packets, you're actually going to go back to lesson um, 6.5, the worksheet that I gave you yesterday. And we're going to do the last question on that blue worksheet from yesterday. So the last question talked about or talks about two companies that offer boat rentals. The Allagash boat rental requires a $20 deposit. Let me get my pan set. It requires a $20 deposit, and then it charges an additional fee of $30 each hour. On the same lake, Bubbles' boats requires a deposit of $10 and the cost doubles every hour. We are going to write equations that represent the cost of renting a boat from each company based on the number of hours of rentals. So for Allagash, the total cost started with a $20 deposit and increased $30 every hour. So we have rental cost in dollars. If we have rental hours along the bottom, our Bubbles is boats. Let me try writing that again. That is not working very well. Okay, here we go. For Bubbles' boats, we had a different price scheme. For Bubbles, it starts at a $10 deposit, and Bubbles doubles every hour. So now we're going to graph these two equations on our grid. So we'll do the line first. I know it's a linear equation because we're just adding $30 every additional hour. Our y-intercept starts at 20. We've got some numbers cut off here, but this is 50, this is 100, so our scale is going up by tens. So my y-intercept is at 20, and it goes up $30 every hour. So keep in mind and be careful about the scale. So our scale along the y-axis for cost is jumping up by tens. So up 10, 20, $30 over 1 hour. 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 And there's our line. And I'm going to label that A for the Allagash Boat Company. Now, for Bubbles' boats, remember that the starting value is the same as our y-intercept. So we're going to start at 10, that's our y-intercept. And it says the cost doubles every hour. So from $10 to start with for a deposit, times 2 makes $20 for 1 hour. And 20 times 2 makes it $40. And then 40 times 2 makes it 80. And 80 times 2 jumps to 160. And then 320, we're off the chart, off the page. So we're going to carefully connect these dots and curve it. It's going to intersect the line somewhere in between here. And then jump up really quick. All right, so part C, the family renting the boat will only be renting the boat for 3 hours. Which company should they rent the boat from? This may be a quick, easy question to answer, but the buggers who wrote this question told us to justify. When it says to justify, that means, friends, we have to show work to justify why we picked which company. So here's what you do. Not a big deal. We're going to find the cost for the Allagash Boat Company. How much will it cost to rent the boat for 3 hours? Then I'm going to use the equation for Bubbles' boats to find the cost for Bubbles' rental for 3 hours. Go to your calculators, type these in, figure out the cost for both companies. Hopefully you're pushing the buttons to get the answer. So if at Allagash, it would be $110. And then over here, 2 to the third power is actually 8. So it would only be $80 for Bubbles'. So which company should we choose? We should choose Bubbles for 3 hours. On the graph, we could probably find the same information. For 3 hours worth of time, we can see that the Bubbles Boat Company is only $80, but at 3 hours, Allagash is up here at $110. So we could get that same information from the graph. Knowing which graph is lower would be a lower price, which graph is higher would be a higher price. So let's do it that way for finding out the cost for 6 hours. Well, for Allagash, for 6 hours of boat rental, we'll read up the sixth line. Oh, it's exactly right at $200, which we could find algebraically if we needed to show our work. For a 6 hour boat rental, we would put 6 in place of our hours, and 30 times 6 is 180, and 180 plus 20 gives us what we just saw off the graph, a cost of $200. Unfortunately, to compare with Bubbles' boat rental, we are off the charts. So for 6 hours of boat rental from Bubbles, we have to use our calculator anyways, because trying to find that information from the graph is not going to work because that point value is too high and it's off the graph. So our total dollar amount for Bubbles' boat company is $640. That's a pretty significant change in price. So it's good to be able to do these calculations because, in real world situation, you'll be able to figure out which company you should use depending on how long you want to be out on the boat. So this time, there we go. Allagash is less expensive. So part E here, if renting the boat for a total of 8 hours, how much money would the family save by going with company A for Allagash? So what we have to do is use our equations, figure out the price for both companies for an 8 hour trip, and then you're going to subtract the $2 amounts to determine how much money would you save. That's what it's asking. How much will you save? Okay, so here's what I want you to do. I want you to pause the video, do both of these calculations, subtract the answers, and let's see how much money you would save by going with Allagash. Then when you're done with and you have your answer, then go ahead and hit play and we'll check to see, make sure you and I ended up with the same value. Okay, so pause it, do the calculations, then come back. Okay, so here's what we got. When you plug in your values for each function, we should end up with $260 as the cost for Allagash and $2,560 for the cost for Bubbles. And then when you subtract them, what you come up with is a ridiculous saving of $2,300. Okay, so that was just an example from yesterday that we didn't get to of how to compare linear and exponential equations. And depending on what you're looking for, you got to know which one works better for the situation. Now, we are over to lesson 7. So now get your notes out, your actual notes packet, and we are going to look at lesson 7. Okay, so for lesson 7, we are going to compare linear and exponential functions, and I'm going to go through each of the different types of ways that you might be asked to compare these two types of functions. All right, so a basic linear function, just like we did back in our previous couple of units, when we're doing graphing lines, we're using the generic formula y equals mx plus b. So a generic example would be y equals 2x. This would have a slope of 2 and a y-intercept of 0. So in the table of values, my y-intercept, because there is no number being added after the 2x, it would be similar to having the equation 2x plus 0. So that would be our y-intercept. And then times 2 means the y value is found by taking the x value and multiplying it times 2. So negative 1 times 2 is negative 2. And then 1, positive 1 times 2 is positive 2. 2 times 2 is 4. And what we're seeing here in the table for a linear function is we are adding the same number over and over and over. Negative 2 plus 2 is 0, plus 2, plus 2, plus 2. So the y values increase by adding 2. And all linear equations will have a table of values where the y values increase by addition. Technically, subtraction is adding a negative, so if it's subtracting the same number over and over, that also counts as a linear function. It just means we're going to have a negative slope. Our generic format for our exponential functions, what we've been dealing with the last couple of days, is a times b to the x. A would be the y-intercept or the starting amount, and b would be our change value. That would be the number that shows how y values change from one to the next. A generic exponential equation would be something like y equals 2 with an exponent of x. So exponential functions have variables as the exponents. This means I would multiply times 2. Now this one, similar to how the y-intercept for our linear equation wasn't shown, so it would be a 0. For exponential, when we only see one number, that implies that our y-intercept or our starting value is actually a 1, because we're using multiplication now, not addition. So that means on my table, my y-intercept, value of y when x is 0, is just 1. The b, the change value here, the common ratio, is 2. What that's telling me is that my y values increase by multiplying 2. So that means in my table, if I know where the y-intercept is, that's my first y value, the next y value is found by multiplying times 2, and then times 2, and then times 2. And if I have to work backwards, I just divide by 2 instead of multiplying times 2. So let's take a look at the graphs. Lines are pretty easy to graph. We've done that before. The y-intercept was 0, 0, and our slope was up 2 over 1, up 2 over 1, up 2 over 1. If we want to do some more points, I can go backwards as long as I know that the slope's positive and my line ends up going up the page from left to right, showing a positive slope. The exponential graphs, hopefully you're starting to be able to pick those out. I don't know why I just said be able, probably because I'm able. So the y-intercept was 0, 1. Then we had some points in our table, 1, 2, 2, 4, 3, 8, and then we're off the charts there. And then going backwards, it was 1/2, 1/4, 1/8, 1/16, 1/32, 1/64. Like I said, that goes right along the x-axis without actually touching the x-axis and curls up and gets rather steep rather quickly. So there's our exponential graphs. Now, a real world situation that we can apply to this, let's say you're mowing lawns and you earn, let's stick with the $2 for each lawn that you mow. Every time you mow a new lawn, you add $2 onto your dollar amount. For the exponential, you're going to earn double the previous amount. That means we are multiplying times 2. So doubling the value means you're multiplying times 2. So if I mowed and got $2 for the first lawn, I'm going to get $4 for the next lawn, and then $8 for the next lawn, and then 16 after that, and then 32 after that, and so on and so forth. So depending on the situation, one definitely has an advantage over the other. Now, in a table, when we're given a table and you're just trying to figure out whether it's linear or exponential, you're going to focus on the y values. That's it. Your focus is on the y values. So 2 to 5, 5 to 8, 8 to 11, 11 to 14. You're looking for the pattern of how the y values are changing. If you can find it, then you know whether it's linear or exponential. This one, we are adding 3 from one y value to the next y value. That means it's linear. On the next one, from 3 to 6 to 12 to 24 to 48, 96, numbers are starting to get too big. What we see is we are multiplying by 2. That's exponential. Multiplication means we have an exponential pattern going on. But what about this one? 10 to 5, 5 to 2.5, 2.5 to 1.25, then decimals. Well, let's look at the whole numbers because those are the numbers that are easier to work with in our brain. From 10 to 5 is cut in half. From 5 to 2.5 is also cut in half. So technically what's happening here, we are multiplying by a half, but that is multiplication and that is exponential. It just happens to be an exponential decay and not an exponential growth. And then the last example in your notes is actually the example that we just did with our practice on lesson 6.5. So we already did this. I renamed the boat companies, but it's the same companies. $20 deposit, $30 an hour, $10 deposit doubles every hour. So we already did this question. You are good to go to ask the sub if she did not hand it out or he did not hand it out yet. I don't know who's there. So ask the sub for your lesson 7.5 practice with linear exponentials. And that is what you would work on Monday, but you still have at least 10, 20 minutes left in class, somewhere around there. So you can start working on that now. And then if you notice up on the board on Tuesday of next week, there is a checkpoint in forms. If you feel like you know what you're doing, you could open that now and do it now. And then Wednesday next week, you'll have a Delta Math assignment, which you could also access pretty soon. Okay, so you can work on any one of those things with what's left in class time and then finish those things for next week. Follow your calendar or take a picture of the board before you leave so you know exactly what to do while you're home. And I wish you guys a happy and healthy weekend. If you have any issues, you can still contact me through Teams or email. And I guess that's it. So be good, be well, be safe, be careful, and I will see you next week. Next week, by the way, when you come back, Thursday is review, Friday's your test.